If the drug has a positive effect and improves performance on the delay of gratification task, then the mean difference score in the population will be positive. If the drug has no effect, then the mean difference score in the population is 0. This is the null hypothesis. To test the null hypothesis, we do a t-test. To compute t, we take a statistic, subtract the hypothesized value, and divide that by the estimated standard error of the statistic. Because we're testing a single mean, we take the sample mean minus the hypothesized value of the population mean and divide it by the estimated standard error of the mean. You might notice how similar this formula for t is to the formula for z that we saw earlier. Getting back to our ADHD example, we still need to calculate the estimated standard error of the mean to complete our formula. The estimated standard error of the mean is computed by dividing the standard deviation by the square root of n. It equals 1.54. N is 24 because there were 24 subjects even though the data from only the first 4 were shown previously. Now we can compute t. The mean of the 24 different scores is 4.96. We subtract the hypothesized population mean of 0, then divide by the estimated standard error of the mean, which we've just worked out to be 1.54. This gives us a t-value of 3.22. To get the probability value of a t of 3.22, we need to know how many degrees of freedom we have. The degrees of freedom is equal to n minus 1, which is 23 in this case. Notice that n is the number of the different scores because these are the scores that we're analyzing. Now that we know the degrees of freedom and the value of t, we can consult the t-distribution calculator or a t-table in a statistics textbook. As shown here in our two-tailed test, the probability of getting a t-value of less than negative 3.22 or greater than 3.22 is only 0.0038. This means that if the null hypothesis that the drug has no effect were true, then the probability of finding a difference between means in the placebo and the drug conditions as large or larger in either direction as the difference found in the experiment is 0.0038, which is very low. Therefore, the null hypothesis that the population mean difference scores is 0 can be rejected. We are justified in drawing a confident conclusion that the population mean for the drug condition is higher than the population mean for the placebo condition. Finally, let's review the assumptions of a single mean t-test. Firstly, we assume each value is sampled independently from each other value. And second, we assume the values are sampled from a normal distribution. In this example, the values are the difference scores.